How do you find one entire polynomial just knowing one of its complex roots? Well, let's find out. Now this problem is telling us to find a polynomial in a quadratic form. We just simply need to find the coefficients a, b, and c, knowing that we only get one little piece of information, knowing that 3 minus 5i is a root for this polynomial, okay? So basically the polynomial evaluated at 3 minus 5i, a complex number, is just going to give you 0, okay? Now, how do we create an entire equation just coming from this piece of information? Now, one root might not seem enough, but actually, just knowing one of the complex roots for this polynomial, we also know the other one. We also know that if this is a root, the complex conjugate root theorem states that the conjugate for this root, so 3 plus 5i, is also going to be 0, okay? So it is also going to be the conjugate for this number is also a root for the polynomial. Now, why is this important? Well, if we say, for example, that we know two roots for a polynomial. So let's say we know p of a is equal to 0 and p of b is equal to 0. Now, something you can create from this information is that the polynomial, since it is a quadratic form, you could factor it out into two factors. So you would have x minus a and x minus b. Now we know this must be equal to 0 because if we plug in as an input a, well, we're going to get a minus a, that's just simply going to be 0, and the entire product is going to be 0, okay? So this must be true if we know there are two roots for a polynomial that are a and b. Now, this is exactly the case that we have up here, okay? We just have complex numbers. So now what do we need to do? Well, that is, I'm actually going to assign values for a and b. So we're going to say a is going to be equal to this root right here, 3 minus 5i, and the b is going to be just the conjugate. So 3 plus 5i. And now we just need to solve this equation or plug in this equation and FOIL the factors, okay? Now we know how much a is, so we have x minus a. What I'm gonna do right now is you could technically plug in 3 minus 5i into this expression, but just for the sake of seeing things clearly, I'm just going to FOIL right now with this form, and then we're gonna plug in the value. So now if we FOIL this, we should get back this quadratic equation over there. So we would have x squared minus bx minus ax and plus ab. Okay, this is the form that we get, and this is going to be equal to 0. Now what you can do now is you simply plug in the values that you know. So you get x squared minus bx, so b we know how much that is, so we're going to have x times 3 plus 5i minus x times a, 3 minus the conjugate of b, so 3 minus 5i, and now the product between these two guys. And that is just simply going to be, I want to show you something pretty cool right now. If you have a conjugate and you're multiplying those two conjugates together, what do you have? So this is something that I want you to see. If you have a plus v times a minus v, well, you know from your basic algebra classes that this is just simply a difference of squares. You can just grab this factor and put a square on both of the terms. And that is exactly what we have with a and b. We're just simply saying in here that we've got 3 minus 5i times the conjugate, 3 plus 5i. So this is a difference of squares, and we can take this, we can just literally grab this and square it. I'm not sure if that is even a verb, square, yeah, I think it is. But yeah, you know what I'm saying. You can just take the square of that, and you're gonna find these the product between the two roots. So now let's complete this equation. So what should we get from here? We're gonna get x squared minus 3x plus minus 5ix minus 5xi minus 5xi. You should place the x before the I because you remember you place last the terms that have a lower degree, or in this case the complex numbers or the imaginary part. So you have minus 5xi, and now you have minus 3x plus 5xi plus, so we can grab that and we're just going to have 3 squared minus 5i squared. This is what we get. And now from this you can get this is equal to 0. This was also equal to 0. You get x squared minus 6x. Now these two, you can see the imaginary parts, they're going to cancel out. That is one way that you can see that your process is actually working. So we get no imaginary part. And now this is just simply going to be 9 plus 9 minus, and this is just simply going to be, you can distribute this. I'm going to do this separate so you see it. This is just simply distribute. So you have 25 times the square root of -1 squared, okay? And now you can cancel out the radical and the square, and you're just simply going to have minus 25 times -1. This is just simply going to give you positive 25, okay? So we have plus 9, and then we also have plus 25, okay? And this is just simply the equation we are looking for. Plus 34. And this is the answer we are looking for, okay? So I hope you guys know what I did. This is a pretty clever way to approach a problem like this when you are only given one root for a polynomial. You can just simply create or go on from an assumption that if these are the roots of a polynomial, then this condition must be true. And then you can just FOIL everything and you can just play the algebra and you're gonna find everything that you need. So I hope you guys enjoyed this video and we'll see you in the following one.